Hello, my name is Lori Ann Walmer. Meet my family. This is my husband, Dan. In this picture, we are celebrating our 25th wedding anniversary. This is our daughter, Jenna. She is a senior at Bridgewater College, and this is Jamie. She just completed her first semester at Eastern Mennonite University. I am a middle school mathematics teacher. I started at Elizabethtown and currently teach at Donegal Junior High School. I am also a Builders Club advisor and a member of the ACTE team. Outside of home and school, I'm very active at my church. I also enjoy traveling, particularly camping and hiking. Along the way, I enjoy photography and scrapbooking. Why STEM? STEM activities allow students to be more involved in their learning, provide real-world examples for the course content, and ties mathematics to other subject areas. I have found that student engagement, applications, and interdisciplinary connections stimulate more interest and improve retention of math concepts. How do students learn science? Chapter 9 from the book How Students Learn, Science in the Classroom, provides 3 principles that answer this question. Principle 1, addressing preconceptions. Students come to our classes with varying backgrounds and preconceptions. Unfortunately, as stated in this text, these conceptions are scientifically limited or incorrect. It is important for teachers to identify student misconceptions and replace them with ideas that are scientifically more accurate. The second principle is knowledge of what it means to do science. Rather than having students follow a set of steps, they should explore science through inquiry so that they can connect observation to theory. The final principle is metacognition. This encourages students to be reflective about their learning and thinking. The example of Thinker Tools, a physics curriculum that uses scientific inquiry with a reflective assessment piece, shows how metacognition can help students find and fix their own misconceptions. What are the barriers to science learning? Preconceptions. An important quote from the first chapter of the book How Students Learn answers this question. While prior learning is a powerful support for further learning, it can also lead to the development of conceptions that can act as barriers to learning. If the preconceptions are not identified and exchanged for accurate information, students will struggle to grasp the new concepts. So let's talk about my classroom. The section titled Learning Environments and the Design of Instruction found in Chapter 1 resonated with me. I make a conscientious effort to create a respectful community where students feel safe to take risks and ask questions. Aligned to Donovan and Bransford's learner-centered environment, I use pre-tests to determine what the students know and use that information to design units. As a knowledge-centered classroom, I organize the Common Core standards in a conceptual framework and connect the topics to create a big picture for students. Finally, I use formative assessments daily to closely monitor the work of my students. By doing this, I can help individual students and address common mistakes as described by Donovan and Bransford. What is my STEM perspective? Similar to Bibby's, STEM means science and incorporates technology, engineering, or math. To me, STEM means math and incorporates science, technology, and/or engineering. In my position, my primary responsibility is to teach math. My goal is to include more science, technology, and engineering activities as applications or connections to the course content. While Bybee has the entire small circles drawn inside the larger circle, I chose to have partial circles lying within the math circle to show that parts rather than the whole of those disciplines are embedded in my math course. I also overlap the smaller circles of engineering and science with technology because some of the science and engineering activities use technology. In closing, I love chocolate, but my favorite is the Twix bar. Happy holidays!